Basically, it offers a chance of catching an error and actually correcting it rather than crashing the program. Instead of just having a function return false for failure, an exception can be thrown. Then users are informed that an error has occurred in a professional manner. Exception handling also benefits in many other ways. Separate code that handles exceptions from the main logic of the program. In traditional programming, error detection, reporting, and handling often leads to confusing code, but exception provides the means to separate the details of what to do when something out of the ordinary fashion has happened from the main logic of a program. Removes excess code that can blot the program through error handling. Compiler will remind the programmer about particular types of exceptions that must be dealt with. For example, I/O exceptions. Control of the program is swapped from the location where the exception occurred to the location where the exception can be handled. Each error has an object that represents it, and therefore code can be written to deal with specific types of errors. For example, a number format exception and a class not found exception can be dealt with in entirely different ways. Exceptions can be caught or declared. This means that an exception can be caught and dealt with within the method that they occur, or can be declared to the calling method that the exception will be thrown back to that method to dealt with. Exceptions can be thrown right way up the calling method hierarchy. Grouping error types and error differentiation allows to create similar hierarchical structure for exception handling. So groups them in logical way. Propagating errors up the call stack lets the corrective action to be taken at a higher level. This allows the corrective action to be taken in the method which is calling that one when an error occurs. Searching backward through the call stack helps to find any methods that are interested in handling a particular exception. A method can duck any exceptions thrown within it, thereby allowing a method further up the call stack to catch it. Hence, only the methods that care about errors have to be worried about detecting them. When it comes to object-oriented programming languages, including Java, the main types of exceptions that are found within them are exceptions and runtime exceptions. Here are some general rules that are to be followed in order to handle exceptions in such programming languages. Rule 1. Handle an exception if you can, or even if it is not visible. Rule 2. Not acknowledge exceptions in model signatures. Rule 3. No handling of technology exceptions in model layer. Rule 4. Fine granularity in model layer, rather global in other layers. Rule 5. Only define really expected exceptions as normal exceptions. Rule 6. Encapsulate normal exceptions in runtime exceptions while using visitor interfaces. Rule 7. Give no null reference. Get no null reference. Build type not set objects to avoid null pointer exceptions. This video discusses about how the exceptions or the errors are handled in different programming languages and how important that concept in programming. By using exception handling, we can avoid unwanted results in our program. On places where we know our code may execute in an unwanted fashion, we can surround it with exception handling block to ensure that our code doesn't disrupt the application flow.